Hey, what's up, guys? Today we are going to go over dilations around the origin, or centered around the origin. So, firstly, uh, dilation is the enlargement or reduction of a figure. So, dilations are actually the first transformation we go over that's not a congruent transformation because your shape actually does change in size. So, the scale factor indicates how much the figure will enlarge or reduce. Variable of scale factor, we typically just denote the scale factor with the letter K. If K is between 0 and 1, so essentially a fraction that's less than 1, or a decimal that's less than 1, and also positive. If K is between 0 and 1, the dilation is a reduction. So you start off with a bigger shape, go to a smaller shape. So big to small is reduction. So on the other hand, if K is larger than 1, then the dilation is an enlargement. So enlargement. So you go from a smaller shape to a bigger shape. Our rule is you go from your original ordered pair x comma y to kx comma ky. So you're multiplying x and y by the same scale factor in order for it to be a true dilation. So let's look at an example real quick. So in the following diagram, ABCD was dilated around the origin to form the figure LMNP. What is the scale factor for the dilation? So on this one, we have our before and after image, or our pre-image and image. So let's choose a point on our original, and let's choose that same corresponding point on the other shape. So A and L are corresponding points. So let's look at the ordered pair for A. A is at 2, 1. So that's from our pre-image, the original. And it transforms to, and then let's look at L. So this is A, and this is L. And you really could also call it A prime if you wanted to, but they called it L, so we'll just stick to that. So L is the ordered pair 4, 2. So what they want us to find is the scale factor for the dilation. So basically we got to ask ourselves, how do we get from 2, 1 to 4, 2? Well, clearly we just multiply 2 and 1 by 2. Our scale factor is 2. You can also think of it as, you can choose X or Y, but it'll be your new coordinate or number over the old one, or original, new over old. So 4 over 2 gives us 2, and 2 divided by 1 gives us 2. Because again, this is the new one. This is the transformed figure. The original one is 2, 1, or the blue figure here. So, okay. Go down to the next part. So A, the line segment, AD, and LP are corresponding sides. And that kind of follows along from what we said by clearly seeing that A and L are corresponding vertices. This side and this side are corresponding sides. And also, measure angle, or angle C, and angle N are corresponding angles. So this angle here and this angle here. Some other properties. The pre-image and image of dilations are similar. they are the same shape, but they are different sizes, which is exactly what makes it not a congruent transformation, although the corresponding angles are congruent. So the corresponding angles are congruent. The corresponding sides are parallel. I'll abbreviate that, but they're parallel and proportional in length. Okay. Let's look at another example. Okay. So graph the image MATH if it is dilated around the origin with a scale factor of 3. Okay, so our K is 3. So simply all we do is we take all of our ordered pairs, which have already been told to us right here, and we just multiply the X and Y by 3. So to put that in coordinate notation, X comma Y is going to go to, well, in general, let's keep general first. It's Kx comma Ky, which in this case in particular means we go from X comma Y to 3X comma 3Y, because that is our K. Okay. So M is -2 comma 1. So multiplying both of these guys by 3, we have -6 comma 3. So let's plot that, -6 comma 3. 1 comma 1 goes to 3 comma 3. 3. So this is M prime. This is A prime. 1 comma -2 goes to 3 comma -6, which is right here. This is T prime. And H prime, -2 comma -2 goes to -6 comma -6, which is right here. This is H prime. And I'm going to try to connect the dots. It's not the most straight, but it is also the same shape, which appears to be a square, but it is 3 times as large because of the scale factor. And that pretty much sums it up. That is dilation around the origin. Thank you.